All right, let's look at the homework 3.7, problem number 9. All right, it says that use a graphing utility to graph a function, but here I'm going to try to do it by hand. All right, so you have this rational function, and we know that the domain is going to be x equals 1 would be bad, so all real number except for 1. So domain of G would be x is not equal to 1. So 1 is the only bad number. All right, but we can simplify this, right? Other than we cannot have x equals 1, we can factor out the numerator as x minus 1 and x plus 4. You can see that if you multiply out, you get the numerator there. You have x minus 1. So we can actually cancel out a common factor on top and on bottom, x minus 1. All right, so this simplifies to just a linear function, x equals 4. But remember that we cannot have x equal 1, right? So x plus 4 is going to be just a straight line. Y-intercept is 6, and the slope is 1, all right? So we know how to draw that, right? All right, go up here. All right, so this is slope is it's negative, so this isn't it. So this is negative. All right, so this looks promising. So you can see that y-intercept is 4 and slope looks like 1. And more importantly, when x equals 1, it's undefined. So this is the correct picture, right? And just for the heck of it, look at this one, right? This has the wrong y-intercept. So you can see that this is the correct picture. All right, let's check the answer. All right, it came back and looks like we have the correct answer, all right? And oh, actually, there are more questions here. Explain why there is no vertical asymptote when a superficial examination of the function may indicate that there should be one. All right, so it's tempting to say that there's going to be a vertical asymptote at x equals 1. But this is not the case here because x minus 1 factor is actually included in the numerator as well. So you get to cancel them out. So there's no blowing up behavior at x equals 1, right? So which one would that be? All right, when factors out, the resultant function is a linear in nature, but still undefined at. So this is exactly it. All right, factors out, vertical still exists, so that's not it. All right, factors out, cancellation transforms vertical asymptote to a horizontal. That does not happen. Cancellation eliminates the domain restriction. It doesn't. And the resultant function, a constant, is not a constant, which cannot have. Okay, so number one, first one is the answer. All right, let's check the answer. All right, I came back and looks like we got the correct answer there. All right, that's it. I hope that this was clear.